So we're going to kind of piggyback off how we ended last time, and we're going to talk about neural adaptations first because they appear to be the adaptations that cause those initial gains in strength. And so these are our two objectives. So what are the neural adaptations and what's the benefit of these adaptations? And there's actually several adaptations, right? So we've got 6 of them here that we're going to talk about. And we're just going to go in the order that they're listed here. So to start off, synchronization. Okay, what is synchronization? Well, generally speaking, we don't recruit motor units all at the same time. This is referred to as an asynchronous recruitment. As a result, you've got different motor units firing at different times, which will actually limit force production, right? Going back to that tug of war analogy, if I want to generate the most force, I need everybody pulling at the same time, everybody on my team pulling at the same time. After training, what happens is our brain learns how to fire motor units synchronously. So as a result, now all that tug of war team, they're all pulling at the same time. They can generate more force. And this ties into recruitment. Okay, so with training, we recruit more motor units. What's the benefit of that? Well, remember, one motor unit is a neuron and all the muscle fibers. So as a result, we excite more muscle fibers. Remember, we excite them maximally through the all or none principle. This causes the release of more calcium. And with more calcium, we get more cross bridges, more force. Remember, cross bridges are always the answer, except on those occasions when they're not. But oftentimes when we're talking about muscular force, we're trying to increase the number of cross bridges. Okay? To help excite and generate more force, we also experience what's called rate coding. Okay, and we've talked about some of these things before. And so with resistance training, that increases motor drive, or in other words, your brain can send more signals, and it can send more signals more frequently. Okay, and as a result, I can generate more force. Okay, because I'll generate more force as I'm recruiting these motor units more and more often. We're going to have faster cross-bridge cycling or more frequent cross-bridge cycling. And as a result, there's more force. Along those same lines, not only are we going to produce more force, but this force is going to be able to last for a longer period of time. Okay, so this is really what neural drive is. It's that motor unit recruitment and rate coding. You need both. So this is the central nervous system talking to the peripheral nervous system, which then talks to the muscle fibers. Okay, and so as a result, with this increased neural drive, we might have that increased rate coding, which is the ability of a motor unit to fire more often. There's also going to be less inhibition. Okay, and so resistance training appears to increase these things. Okay, increased neural drive. Excuse me. All right, and then we've also got autogenic inhibition. Okay, GTOs. We talked about those a few weeks ago. Remember, GTOs inhibit. All right, they produce our muscles from producing excessive force, and so as a result, with resistance training, we reduce the effects of those GTOs, and this allows more force to be produced. I don't have a picture of it. I wouldn't show a picture of it or the video, but a few weeks ago there was a guy that was trying to bench press a massive amount of weight, and in doing so, he ripped I think it was his pec right off the bone. Okay, and this likely happened in part because due to his training, he has reduced inhibition from his Golgi tendon organs. We've talked about how oftentimes these big, massive injuries don't just happen to the typical athlete. Okay, they happen to highly trained athletes, and the reason why is because they've been able to inhibit those protective mechanisms. And then the last thing is coactivation. Okay, when we're doing a movement, if we want to generate more force, well, we want to activate muscles that will help generate that force, but we also want to inhibit muscles that will oppose that force. So just like I've got here, if you're doing elbow flexion, you want to activate your biceps, inhibit your triceps. And by activating these agonist muscles and inhibiting the antagonistic muscles, we're able to increase force production. And that's where we're going to end for the neural adaptations.